Hey you guys, this is Mr. Sal. This is just a quick lesson on synthetic division. So we did division of polynomials. Now we can use a special method with synthetic division to hopefully make it a little bit easier. So thanks for watching. Don't forget to like, comment, and subscribe. The special case, by the way, for synthetic division is that the divisor or the it's the same word from before. The denominator still has to be in this form, x minus c. So the coefficient of x has to be 1, and it's not x squared or any other exponent with x, just x minus some value. And when this happens, it creates a very unique scenario for us, and that scenario is synthetic division. Alright, so I'm going to show you guys synthetic division simultaneously with long division, so hopefully it will kind of make sense with this. Alright, so if this were long division, first of all, because that's what we're used to right now, we would take our x cubed plus 5x squared, all cubed, plus 13x, oh man, plus 22 divided by x plus 2. Alright, so from here, and again, it would be important to fill in any empty spaces with the 0 degree, or the 0 coefficient with whatever degree it is. But in this case, okay, so still using long, we'll go through the long division first, and then we'll look at how it relates with the synthetic division, okay? So, how many x's go into x cubed? X squareds of them do. And x squared times x is x cubed. X squared times 2 is 2x squared. That's what we're getting rid of right there, right? And that leaves us with, I'm not going to show any cancellations on this because we're going to need it with synthetic division. So 3x squared, and then we'll drop the rest. And now how many x's go into 3x squareds? 3 x's of them do. So that gives us 3x squared, which cancels that out. And 3x times 2 is 6x. And again, that's what we're taking away there. So I'm left with 7x, and then that plus 22 right there. Alright, then how many x's go into 7 x's? 7 of them do. 7 times x is 7x. And 7 times 2 is 14, which we're going to take away there. And we have a remainder then of 8. So this would be our answer using long division, okay? But again, let's look at this in terms of synthetic division now. And hopefully this will help us make sense of what the heck is going on in synthetic division, because it really is just kind of like a rule, but it works. And some of you guys noticed that from the rule is there were some problems on 5-6 that we could have used synthetic division because it was just an x minus whatever it was, c, right? All right, so the rule is that for synthetic division we needed x minus c, but this one is showing as x plus 2, right? So that would mean that to make this an x minus c format, I'm going to have to make that x minus negative 2. All right, that's important to acknowledge because this negative 2 is one of the key, I don't know, it is one of the key values we're going to be using. Here's how synthetic division works, okay? So, in general, we always start with a little box right there. I'm envisioning that as a box, okay? The c value, which we just discovered is negative 2, goes inside that box. Is it getting funky already? Kind of like a video game, right? Well, maybe not quite, but I don't know. Now, the rest of the values, right now, I'm just looking for the coefficients of the numerator, or I guess that was the dividend. So, if I went along this, I've got x cubed, its coefficient was 1. I'm just listing these left to right. The coefficient of x squared was 5. The coefficient of x was 13. And then x to the power of 0, essentially just the constant, is 22. All right, now it is crucial that these are in descending order, though. All right. Now, again, we'll compare this as we go with long division, okay? So the first step is to bring down whatever the first value is, and right now that is 1. 1 right there. Okay, now I guess it will help if we see the answer to relate the two. The next step is to take the 1, multiply it by our boxed number, -2. 1 times -2 is -2, and I put that underneath my next number, which was, in this case, the coefficient of 5x squared, -2, right? All right, now before I continue, just looking at what I added and subtracted right there, right? I dropped the 1, and then I got that -2. That -2 is represented by this -2x squared. Right? Because now when I subtract, what do I get? I get 3. All right? Well, I'm going to do the same thing on this one. I'm going to take 3, multiply it by -2, which is -6, which was also shown in the long division. And I'm going to put it right here as -6. So now I'm going to combine 13 and -6. And that gives us positive 7. Thank you. Well, okay. Now let me use a different color here. I'm going to multiply 7 by the -2, which is -14, right? And we can see that in the long division. 7 times -2 is -14 here, right? And we even had that 22 right there, right? 22 minus 14 is 8. And that last term, I guess, is always our remainder. The remainder is always this last part. So if it were 0, we would have no remainder. It's unfortunate we haven't seen any of those. But now, to show the actual answer for this, we're gonna start with x's, but we want to look at the x cubed that we started out with and just drop it 1 degree, okay? And what was that? That'd be x squared then. And then the next term, that's a positive 3, by the way. The next term down in degree would be just an x. And then that's a positive 7 right there, which was shown up here. Okay? And what was our remainder? Yeah, sure enough, it was 8 as well. Okay? So we have our quotient right here with our remainder. Done. Yeah, that's a good point right there. The c value is what goes inside the box. And if it was already x minus 2, the c value is 2, and I would make that a positive 2 for that.
Oh, I see.
All right, so this one is already in the c value, right, for finding our c value. We already have the the divisor in this form x minus 2, right, because we want it to be x minus c. So the c value, right, x minus c, the c value is just 2, not -2 now. So when I look at my box value, I'm going to shove that 2 in there. And now I'm looking for coefficients of all of my terms, as long as that's in descending order, right? So we probably should double check to make sure it's in descending order. 4, 3, 2, 1, 0. So we're good there. So the coefficient of x to the 4th is 1. The coefficient of x cubed is -10. Coefficient of x squared, 17. Coefficient of x is 6. And then coefficient of x to the power of 0, which is just 1, you guys. That's -10. It's the constant. All right, I'll draw us a little line there. All right, starting with the 1, we're just going to drop that. Always drop that first one. It's 1. Bam. Next up, I've got 1 times 2, which is positive 2, which I'm going to combine with that -10. That's going to be -8. So I'm going to take -8 there in red, multiplied by our boxed 2. That's -16. So 17 minus 16 is 1. 1 times 2, is 2, which is positive. 6 plus 2 is 8. 8 times 2 is 16. That's positive. And negative 10 plus 16 is 6. That last number, of course, is our remainder right there. But what's the rest of this? Well, our highest degree was 4, so we're going to drop the answer with 1 degree cubed minus 8x squared. That's a positive 1x plus 8 with a remainder of 6. So this is our quotient here. This is our remainder. Just real quick, right, you could write this all out as one expression just in case they ask for it. So it's just a possibility. You may have to write it like this right here. So once again, this should be in the form x minus c. So we're just going to show it as x minus negative 2 instead of x plus 2. So that shows us what to put in the box, right? That negative 2 value. And then I'm looking for coefficients of my numerator values. So what do I got? 1, 6, 16, and 23. All right, well, that's a good start. We'll drop the 1. 1 times negative 2 is negative 2. 6 minus 2 is 4. 4 times negative 2 is negative 8. 16 minus 8 is 8. 8 times negative 2 is negative 16. And that gives me that remainder of 7 right here. So just looking back, we got that x cubed, so I'm going to drop that 1 degree to make that x squared. That's a positive 4x plus 8. There's our quotient with the remainder. More synthetic division. You guys tell me what goes in the box.
-5.
Very good. -5. Then we got coefficients of 1, 6. There is no x squared. Yeah, so we got to put a 0 there. Negative 23 and 15. All right, first of all, always drop the 1. 1 times -5 is, well, -5. 6 minus 5 is 1. 1 times -5 is -5. 0 minus 5 is -5. -5 times -5 is 25, and that's nice because it'll kind of equal out that negative 23. It's positive. So we end up with 2 there. 2 times -5 is -10. And 15 minus 10 is 5. So that's going to be our remainder. Remainder of -5. We'll just fill in the degrees here. So we started with x to the 4th. So we're going to drop it 1 degree, x cubed. It's a positive 1. X squared, x, and then no x right there. And that right there would be our quotient. You don't really have to include the 1 there either.
Can I ask?
So this one also is missing that plus x, so we're just going to write it in as 0x so that we show it fully in descending order. Now this x minus c business, right, this is really x minus -5 instead of x plus 5.
So basically it's a positive.
Yeah, you can just take the opposite of whatever that value is. Yeah. Which is kind of what the minus, I guess, is telling us.
Right.
Yeah, that's a very good point. So in the box, I'm going to put my -5, and then I'm looking for my coefficients in descending order there. I got -1, 4, 1, 0, and 4. As usual, drop the first value, -1. -1 times -5 is 5. 4 plus 5 is 9. 9 times -5 is -45. 1 minus 45 is -44. -44 times 5, -220.
It should be positive.
Thank you, positive. So plus 220. 220, getting some big values here. 220 times -5, -1,100. All right, so 4 minus 1,100. Well, I mean, not that we may feel a little uneasy about these numbers because they're much larger than what we've been used to seeing. But it looks like we did that correct. So our remainder is negative 1096. And then again, we're going to drop the degrees here, starting with the first one, x cubed. That's a positive 9. That'll be x squared, negative 44x, positive 220. And that right there would be considered, for the homework, our quotient. The remainder theorem isn't really a big deal. Just kind of is a nice way to find the remainder, I guess. So if a polynomial p of x is divided by x minus c, so that's synthetic division stuff, then p of c, right, whatever that c value was from the denominator, is the remainder for, well, p of c. Okay. So the remainder theorem, let's apply it to that last problem that we just did, right? So we see the remainder, what it is. And so if I made this some kind of function, right, the original expression, and we'll call it p for polynomial of c, and we already know the c value of this was negative 5. That means if I solved for where, in this case, x is negative 5, or the polynomial where x is negative 5, then I would get negative 1096, which was the remainder. That's all it's saying right there. So given this function, f of x equals 6x squared minus 3x plus 7, calculate the following using synthetic division. Well, dang it. That's lame. Fine, whatever. And then whatever the synthetic division gives us as the remainder is the answer in that case. So part of this is knowing what we actually are dividing by, right? So this is giving us the c value of that first one. We just got to do it 5 times. But it's not too bad because they only gave us 3 terms in this. So the c value here is negative 2. And I've got coefficients of 6, negative 3, and 7. The remainder of this is going to be what I put in for f of negative 2. So what this would be doing is I would be dividing it by x minus the c value, right, which is negative 2, which would make it x plus 2. So we'll just run through this, drop the 6. 6 times negative 2, negative 12. So I got negative 15 here, times negative 2 is 30. So my remainder here is 37, which is the answer for f of negative 2. All right, well, let's try this with c being negative 1. So once again, I'll drop the 6 times negative 1 is negative 6. So I get negative 9 times negative 1 is 9. 16, there's my remainder. F of negative 1 is 16. And yeah, again, it would be the same as dividing this by x plus 1 in that case, right there, in the purple. Now, could you check this? Sure you could. You could actually do, for f of x, just replace the x's with negative 1 and see what you get, right? Since that's a lot easier, I'm going to do it for 0, just to show that this works, okay? 6 times 0 squared is 0, minus 3 times 0 is 0, plus 7 is 7. All right, well, let's do 1 as well. So in the box, I got a 1, 6, negative 3, 7. So I'll drop the 6, times 1 is 6, negative 3 plus 6 is 3, times 1 is 3. Yeah, I'm going fast, so that usually means I'll make a mistake. I think I'm doing pretty good, though. I think. So there's the 1. Finally, let's do the 2. So I got the 2, 6, negative 3, 7. 6 times 2 is 12. And what do I get here? 9, 18, 25. 25. That was my remainder. Bam. For the given polynomial p of x and the given c, which they've given us 2, use the remainder theorem to find p of c. So they're really just saying find P of 2 on this. Using the remainder theorem means we'd have to use synthetic division, not that everyone would, but we can do it. 2 in the box, we got 1, 5, -4, and -6. Let's drop the 1. 1 times 2 is 2, 5 plus 2 is 7, 7 times 2 is 14, -4 plus 14 is 10, 10 times 2 is 20, -6 plus 20 is -14. So P of 2 should equal -14.
Regular 14?
Oh, yeah. See what I mean by going real fast right there? Thank you. That's a positive 14. Now let's check, just to be sure. So I got 2 cubed. Whoa. 2 cubed plus 5 times 2 squared minus 4 times 2 minus 6. And we should get 14 out of this, right? So 8 plus 5 times 4 is 20 minus 8 minus 6. I get 14. So that checks off. So 14, using the remainder theorem as well, whatever, it works.